Okay, today we're going to do our chemistry lesson here. It's on covalent bonds, or different types of bonds. So my teacher actually put in several problems that we're going to work through with the AI. Let's get started. And I also have my board here on the
Hi, I'm
right.
Professor Samantha Cruz, your chemistry guide today. Let's dive into chemical bonds, covalent, ionic, and hydrogen. We'll start with ionic bonds. Consider sodium chloride or parentheses NaCl close parentheses. Can you describe the electron transfer process when sodium and chlorine form an ionic bond?
I think that sodium gives one electron to chlorine, right?
Exactly. Sodium, spoken as Na, loses an electron, becoming Na+, and chlorine, spoken as Cl, gains it, becoming Cl-. This electron transfer stabilizes both elements. Now, let's calculate the lattice energy. If the energy released when Na+ and Cl- come together is negative 787 kilojoules per mole, what is the lattice energy?
How do I calculate lattice energy from that number, 787 kilojoules per mole? Can you explain that to me?
Certainly, in this case, the lattice energy is the energy released when the ions form a crystal lattice from gaseous ions. The value given, negative 787 kilojoules per mole, is the lattice energy, as it represents this exothermic process. Let's move on to the next question about covalent bonds. How about you draw the molecular structure of carbon dioxide and explain the electron sharing process?
Okay, so we're going to use our whiteboard here and draw the structure. Um, let's say I draw it here. Erase this, try again. Okay, let's submit this and see what it says.
Your drawing shows the elements well, but CO2 is linear. Carbon shares two pairs of electrons with each oxygen, forming double bonds. O double bond C double bond O. Why do you think this molecule has a linear shape, and how does this affect its polarity?
So you see, it caught our. I drew it in a non-linear way and also missed the double bond here, so it caught that part. Let's do one more thing. Um, it has a linear shape. I don't know why it has a linear shape. Can you tell me?
Sure, in carbon dioxide, the central carbon atom forms double bonds with two oxygen atoms, using linear arrangement to minimize repulsion between electron pairs, according to VSEPR theory. This symmetry gives it a nonpolar nature as dipoles cancel out. Now, let's explore ammonia, written as nitrogen H3. Could you visualize its structure and explain how hydrogen bonds form between molecules?
Okay, so now I'm actually going to use this camera feature here, and I have it drawn here, and then I want to put, um, let's say, a lone pair there.
Great drawing. Ammonia has a nitrogen atom bonded to three hydrogen atoms with a lone pair on nitrogen. Hydrogen bonds form between the lone pair of nitrogen in one molecule and a hydrogen atom of another ammonia molecule. How does this bonding affect ammonia's solubility in water?
Okay, so we're going to go ahead and end our lesson here. It's going to keep going and keep asking questions that the teacher has inputted. But let's get our evaluation. My teacher will see the evaluation as well as the transcript. 4 out of 5. Not too bad. I wasn't sure about certain things, but yeah, pretty reasonable.